everybody should know learn Ohm's law, how to light an LED. When I go around my house at night, I probably have 15, 20 LEDs. Red ones, green ones, blue ones. So everything you've got, turn on a switch, probably turns an LED on. Ohm's law. Kepler's law in physics says that nothing is in a circle. Okay? So everything in space is in an eclipse. That one thing I just showed you is not a circle, it's an eclipse.
Wash your hands.
Okay? Far, near, near, far. So it's not like this. So unless you control it, like our satellites are, it's not in a circle. So when the astronauts are up there, or we send our last Artemis 1 up there, we have set the world record for the furthest away from the moon of anybody's ever been. Any device. Okay? I learned this from CTC Planetarium. Never go out. It's worth going out at least one time on a Friday night. You're warned. Warren Hart at the last Friday usually of each month gives presentation for what's going to happen the next month in the sky. So it's good to know if you go into astronomy. So the next thing that you've got to get through your head is we make that nice globe. I've got some globes over there when we get there. That's the Big Dipper. So, and this is what I'll get across to your parents too. I grew up in, most of us grew up in a 2D world. We're no longer in a 2D world. We're now in a 3D world. Our drones are taking off and flying all over. So that 2D world, that mile down here is not the mile up here. This is a spherical mile, spherical geometry, a nautical mile. When you're in an airplane, you don't fly land miles. So you've got to realize that when you look at the star, see that we look at it like this, but it's not. It's three-dimensional. So this is where the brain has to start kicking in to realize. So in astronomy, and this is worth writing down too, when you start buying equipment and learning astronomy, there's different stages of it. The planets are part of our solar system. Just one stage. One type of telescope, one type of binoculars for the planets. Not to look at Betelgeuse up here, not to look at Rigel down there, whatever, I'm sorry, that's an Orion, but not to look at the stars. Looking at the stars is what we call deep sky. It demands a lot more time, effort, and money. But anyway, but to realize, again, we're in a three-dimensional world in astronomy. Okay, do we have any volunteers? No? We've got lots of stuff for you to look at here. This is where we start. This is made by the planetarium in Chicago. That's where I went to medical school. Okay? So, first thing is, this is what I'm talking about here, a nice flat circle. It ain't right. It ain't a circle to start with, and it's not flat. It goes millions of light years out that way. Some things close, some things far away. So, as you move up in astronomy, and this becomes fairly important when you start handling these tools. Okay? First thing to get through is the Earth, the universe, and the sun. This is supposed to teach you the sun. As I said, we go through this over the whole year. The sun's up here. So, the important days to know, again, it's worth writing these down. They do affect your life. December 21st, March 21st, June 21st, September 21st. So let's start with winter. Where is the sun? December 21st. Down in South America. And then it's going to come up to the equator, which I could see when I was in Panama. And that's called the equinox. Equinox.
When is that?
Then it's going to come up to the high sky. So that's about 30-some degrees up and 30-some degrees below. Each of these starts a season. That's the start of summer, hot. It is down here, December 21st, cold. Okay. Therefore, that's also long days and short days. Down here, it's the longest night of the year, December 21st. And then we're going to go back down to September 21st. Equinox again. Vernal equinox, autumnal equinox. So anyway, that's the important thing on seasons in astronomy. Jerry, let me know when I'm up in time. I'm fairly good, but I can't see her. Jerry Shishoka back here is going to give a presentation on the new telescope. I would highly recommend you won't buy this for your kids at Christmas time, for the family, or whatever. It's only $500. It does unbelievable things. You can take it out CTC and watch the birds fly. Little birds they got out there. It'll track them through the sky. You can get video of it. It does all kinds of things. If you bought this one 2 years ago that I was going to buy from Europe, it was $3,000. I decided to wait like I do. And it come out 2 of them from China for $500. So I bought 4 or 5 of them. And there's further around now for the eclipse. I highly recommend you get your kids a 3D printer. Real cheap, easy. It's unbelievable what they're going to learn. This is, again, the universe. Here you can see they print it on here. Here they make holes in it. So if you want a CEPHUS, you take toothpicks and plug it in. Then show the teacher or show your mother or father. You can see that there is a learning curve. This guy printed okay. This guy got to the end of it. And, so I can still use it. But I'm saying 3D printing is a learning curve in itself. So a lot of the stuff you can see, it shows you my 3D printed ring. We 3D printed these. Hopefully we'll be 3D printing here soon. Now, I'm going to take my volunteer.
Julia, green jacket, welcome volunteer. Yep.
It's like the Army. You got volunteers. Pick one. what you're going to do, these are magnetic. So take a circle like so. Oh, no, I'm just showing you. Top, bottom, right, left, north, south, whatever you call it, 0 degrees, 90 degrees, all these things you're going to have to learn. So, first thing, we're going to put the king, CEPHUS, on top. Good. You're going to go around the circle. So, you want to go right clockwise or counterclockwise? You'll find this becomes very important too. We tend not to think about it a lot, but in math and science, you must know it. This way or that way. Or in music, the circle of fifths, the circle of fourths. Makes a big difference. You're in the band, we're out here playing an orchestra and a violin. Which way do you want to go? This way or that way? Okay? Move out of the way a little bit so they can see it. The king on top. So we're going to go this way. So down here we're going to put the queen, CEPHUS. Okay? Down here, who else we got? I can't say it.
We have the Big Dipper.
We should have. Put one on, take one off of the other. We got lots of them. That's the dragon. And we've got lots of these, by the way. It's not just here. We could hand them out. Who's that? So anybody wants to borrow these for their school or for teaching or whatever, we've got all this available. I'm saying this is for public teaching and education. And so you can 3D print these out at home too, by the way. With 3D, or you can print them on just a sheet of paper. Let's stay down here for the time being. That's the dragon, right, Rocco? Down here.
This one's the dragon?
No, we should have one for the big difference. We could put them in the middle. Now, this is something to get in your mind. The Little Dipper is part of Polaris, the North Star. So everything goes around the Little Dipper. So find the Little Dipper, 1. 2, once you find the Little Dipper, find the Big Dipper, because the Little Dipper points at the Big Dipper. Then once you've got those in the sky, from there on, it's easy to find CEPHUS and CASSIOPIA. And we didn't know how many people will come, so if you all come back next time, I'll bring some pens and some paper and some drawing, because we want this to be as much as possible hands-on. And we're not going to get too many volunteers, it looks like, so you can do it at your table. So now, the other thing you have to realize, I looked out in Killeen. I live right by Ellison High School. So what you want to do is know when something comes up in the east and goes down in the west. So again, write this down. Sunrise, sunset is an act. Okay, that'll tell you when the sun comes up, when the sun comes down. Now, this is fairly important too. And you go through it every day, but you don't know it. When the sun goes down and when the sun comes up, there are stages. I was in photography for 10 years here in Killeen. doing weddings and see your pictures, you saw something and so on and so on. When the sun is down here on the horizon, okay, so you're going down and it's going to go down. So you go down at 6, 12, 18. So you have civil sunset, okay, or twilight, okay. This is called the golden hour. Let's say a bride and you want a beautiful picture outside the CTC. An hour before sunset, when you go out there, that sun's coming in and you'll have a backlight on your hair that's unbelievable. Okay? So then as the sun goes down, you're at the horizon. As the sun goes down 6 degrees, 12 degrees, 18 degrees, you're going to go through what we call all the way down to astronomical darkness. So you don't do astrophotography until you're 18 degrees below the horizon. Nautical, the sailors, all that means is no buildings, no trees, and so on. When they're out in the ocean, so their world is different than our world. Nautical twilight is down there before astronomical twilight. So it takes about 20, 30, 40 minutes before. So if you say it's twilight, you've got to look for, astronomical twilight, or calculate it out yourself. The next program is called Phases of the Moon. So the next class we're going to give will be heavy on what we talked about today and the moon. We're going to put a man and woman on the moon. We're spending billions of dollars. Okay, so very important that we know the moon. That's called Phases of the Moon. So put that app on your phone. Okay, Jared?